Okay, get this. What if we could make a plastic that's as tough as some of our strongest materials, but it's made, get this, entirely from plants? Today, we're diving into a really cool research proposal for a new material that has a superpower that could honestly solve one of our biggest environmental problems.
Just think about that for a second. Seriously, what if your car bumper could just fix its own scratches? Or a giant wind turbine blade could repair tiny, invisible cracks all by itself long before they ever became a real problem? That's the incredible promise we are exploring today.
Now, to really get why this new material, which they're calling Hempoxies 20, is such a potential game changer, we first have to understand the problem it's trying to solve. And believe me, it is a big one.
So right now, we are kind of stuck in this trade-off. See, on one hand, you've got these super tough petroleum-based plastics. They're in everything. Cars, electronics, you name it. They're strong for sure, but they are an absolute nightmare for the environment. And then on the other hand, you have bioplastics. They're renewable, plant-based, which is awesome, but they just haven't been strong enough for those really heavy-duty jobs. There's this huge gap between the two.
And that gap? Well, it has a number. Less than 60 megapascals of tensile strength. You can think of this as a sort of performance ceiling that most of these structural bioplastics just can't seem to break through. It basically locks them out of all the high-performance jobs we need them for.
So the big question is, how do we smash through that ceiling? Well, let's meet the hero of our story, a material concept that was engineered specifically to bridge this gap between strength and sustainability.
At its heart, Hempoxy 20 is pretty much what it sounds like. It's a high-performance plastic where every single component, everything, the resin, the hardener, even the stuff that makes it strong, is derived from the hemp plant. Just one single, renewable source for the whole shebang.
So, what's the secret sauce? What makes it so special? Well, the magic isn't just in the fact that it comes from a plant, but in how all its different parts are transformed and mixed together. Let's take a look at the ingredients.
Okay, so the foundation of this whole recipe is something called epoxidized hemp seed oil, or EHSO for short. The easiest way to think about it is like a thick, honey-like resin that's going to form the main body of the material. But that resin, it's way too thick on its own. So the researchers propose adding another ingredient called FGE. It's a reactive diluent, which is just a fancy way of saying it thins the mixture out, right? It makes it flow more like water so that all the really important strength-giving stuff can be mixed in perfectly. And of course, you need something to make it all hard and solid. That's where sulignin comes in. It's a specially modified hardener, also from plants, that basically acts like the glue. It locks all those molecules together into a super strong, permanent network. Now here's where the incredible strength comes from. It's not from just one thing, but from building it up in layers, from tiny to large. At the nano level, you have these teeny tiny carbonized hemp nanosheets. Then you add microparticles of biochar. And finally, you mix in even larger milled carbon fibers, also from hemp. Each layer reinforces the next, building toughness from the ground up.
So okay, we've got a really strong, fully bio-based plastic. And you know what? That's already incredibly impressive. But this is where the science gets really, really exciting. This is what gives the material its superpowers.
The key is this one word, vitromer. A vitromer is a totally revolutionary class of plastic. Think about it like this. Most of the strong plastics we use are like superglue. Once they're set, they are set for good. A vitromer, though, it's more like Legos. The connections are incredibly strong, but if you add a little bit of heat, you can actually unlock them, rearrange them, and then lock them right back into place.
This slide just illustrates that difference perfectly. On the left, you've got your traditional thermosets. That's the superglue. They're permanently locked. Yeah, they're strong, but you can't recycle them. On the right, you have vitromers, our Lego bricks. They are just as strong, but because those bonds can be rearranged, you can repair damage, you can reshape parts, and you can fully recycle the material at the end of its life. It's a total game changer.
So what's the magic temperature for unlocking those Lego bricks? Well, the researchers are projecting it'll be right around 60 degrees Celsius. They call this the topology freezing temperature. Below this temp, it's a hard, rigid solid, but you warm it up past that point, and those bonds become dynamic, allowing the material to literally heal itself.
Now, it's super important to remember this is still in the research phase, right? But the performance targets the scientists have set for themselves are, well, they're incredibly ambitious. Let's see what they're actually aiming for.
Okay, so first things first, strength.
A typical bioepoxy, a pretty good one, maxes out around 42 megapascals. The target for Hempoxies 20 is more than double that, a whopping 85 megapascals. That doesn't just clear that 60 MPa hurdle we talked about, it absolutely smashes it. This puts it in a whole new league.
And what about that self-healing superpower? The target here is a healing efficiency of over 85%. That means, after the material is damaged and then gently heated, it's expected to get back almost all of its original strength. We're not just talking about patching a crack here, this is true molecular-level repair. It's amazing.
All right, so let's zoom out for a second and look at the bigger picture. If this research pans out, if they can actually pull this off, the impact could go way beyond the lab. We're talking about something that could fundamentally change how we make, use, and reuse our strongest materials.
I mean, just think about it. We could be replacing petroleum plastics and things like car parts, making our vehicles lighter and way greener. We're talking about a world where high-performance materials don't just end up in a landfill, but are actually reprocessed into brand new products. And on top of all that, we'd be creating a totally new high-value market for an agricultural crop. It's a win-win-win.
Ultimately, this research leaves us with a really powerful question. For decades, we've looked deep underground to fossil fuels for the building blocks of our modern world. But maybe, just maybe, the key to a stronger, more sustainable, and truly circular future has been growing all around us this entire time.